Hey guys, so we're going to start today's video with a review of today's lesson on absolute values. So you should get a pop-up box for these two questions. Okay, so once you've completed the questions, I will show you how to do them. So in the first one, we have negative 13 plus the absolute value of negative 2 plus 5. Remember, you need to do what's inside the absolute value brackets first. So we will do negative 2 plus 5. Since the signs are opposite, we'll subtract, so it becomes 5 minus 2, which is 3. And we take the sign of the higher number, which is 3. So the absolute value of 3 is 3. And once again, we can add negative 13 plus 3, and our answer is negative 10. So the solution to this equation is negative 10. Looking at number 2, we have negative 10 plus 7 plus 2. So we have to do what's inside the absolute value brackets first. Negative 10 plus 7 is negative 3 plus 2. Now we take the absolute value of negative 3, which is 3. 3 plus 2 is 5, so the solution to the original equation is 5. Okay, you should get a pop-up box for these now. Okay, so we need to do what's inside the absolute value brackets first, but in number 3 you can see there's 2 sets of absolute value brackets. That's okay. We handle each one separately. So the absolute value of negative 6 is 6 minus the absolute value of 6 minus 8. Well, 6 minus 8 is negative 2. Okay, so now we can go down to the next line. It'll be 6 minus the absolute value of negative 2, which is 2. 6 minus 2 is 4, so the solution to our original equation is 4. Looking on down to number 4, we have the absolute value of negative 7, which is just 7, plus the absolute value of negative 8 times 6. Well, negative 8 times 6 is negative 48. So we are left with 7 plus the absolute value of negative 48. Well, the absolute value of negative 48 is just 48. So the solution to this equation is 55. And the solution to the original equation would then be 55, because they are equivalent. Okay, moving right along, our new topic is scientific notation. Just wanted to get some vocabulary out of the way first before we continue. The number that you see first, 7.05, it is known as the coefficient. Okay, and that's a vocabulary term that we're going to use often. It's the coefficient. We multiply the coefficient by a number, a power of 10. Okay, the 10 is known as the base. Okay, in scientific notation, your base is always going to be 10. Okay, so this right here doesn't change. The exponent, however, changes. Okay, that's probably one of the more important parts, the exponent and the coefficient. Those numbers will tell you everything you need to know about the number that's in scientific notation. Okay, so let's go ahead and try to work some out now. So here we have number 1, 7.15 times 10 to the third power. What we need to do is we need to look at the exponent. Okay, well, our exponent is 3. That tells us that we need to move the decimal point 1, 2, 3 places. Since the exponent was 3, we moved the decimal point 3 places. You see how at the end there we have a little cup that's empty? But we just need to fill that cup with a 0 and then write it over. So 7.15 times 10 to the third power equals 7,150. Okay, I'll do that again down here on number 2. So 3.04 times 10 to the fifth power, the 5 tells us how many times we move the decimal point. So we'll write 3.04. And we move the decimal point 1, 2, 3, 4, 5 times. As you can see, we now have 3 empty cups. We'll fill those empty cups up with 0. So in standard form, 3.04 times 10 to the fifth power will be 304,000. All right. Number 3, to convert this to standard form, we once again look at the exponent. The exponent is 2. So we'll write our coefficient, and we'll move the decimal point 2 places. 1, 2. Since there are no empty cups here, we don't need to add any zeros. So we could just rewrite 4.123 times 10 to the second power in standard form is 412.3. Okay. Now, when you're given a number that's in standard form and you need to convert it to scientific notation, it's important to note that your coefficients will always be greater than 1 and less than 10. Okay? There are no 2-digit number coefficients. If we take a look back real quick, okay, our coefficient here only has a single-digit number in front of the decimal. And if we look back at our other examples over here, it's the same thing. Your coefficient will always have a single-digit number in front of the decimal. So what we need to do is we need to figure out where we put the decimal point. So in order to make this a single-digit number, we put the decimal point between the 5 and the 4. The only thing that's left to do is figure out how many places did we need to move the decimal point. It originally was here, so it went 1, 2, 3, 4. Since it went over 4, we can rewrite it in scientific notation as 5.45 times 10 to the 4th power. You don't need to write those zeros at the end. Once you see yourself writing zeros, you can stop. Okay? So if we look at number 5, where are we going to put the decimal point? Between the 6 and the 7. Now we just need to count. It went 1, 2, 3, 4, 5 places over. Which means we have 6.7, we don't need to write the last zeros, times 10 to the 5th power. Okay? Number 6, we'll do the same thing. Put the decimal point right here to make it a single-digit number. And we'll move, our decimal point was moved 1, 2, 3, 4, 5, 6 places. So this is equal to 7.2 times 10 to the 6th power. Okay? So these are a little different. As you can see, your exponents are negative. So if you look at the exponent right here, it is actually negative. That just means that the decimal point will go the other way. So we will write 3.45, and since it's the negative 2nd power, we move the decimal point left this time because it's negative. 1, 2. You see how we have an empty cup? We fill that with a 0. So 3.45 times 10 to the negative 2nd power is 0.0345. Okay, if we look at number 2, we'll do the same thing. Write equals 4.18. You know what? We need a little bit more room than that. 4.18 times 10 to the negative 5th power, which means we need to move our decimal point over 5 times to the left because it's negative. So it goes 1, 2, 3, 4, 5 times. We fill all the empty cups with zeros. So our solution here is 0.000418. Okay, looking down at number 3, once again, we have a negative. So we write 6.78. Okay, so we have a negative, as you can see, so we'll write 6.78. And now we'll just count back 4. 1, 2, 3, 4. And we'll fill those empty cups with zeros. which means, and I'm going to just write it down here so I don't run out of room, 0.000678 is the solution here. Okay? It works going the other way too. So here we have numbers in standard form that we need to convert to scientific notation. So we'll do just like we did before. We'll move the decimal point over 1, 2, 3, 4 places, which means that this is 5.8 times 10 to the negative fourth. If we look down at number 5, we're just going to move the decimal point over 1, 2, 3, 4, 5 places. Now it's 6.7 times 10 to the negative 1, 2, 3, 4, 5. There you go. Finally, number 6, we'll move the decimal point over 1, 2, 3, 4, 5, 6, 7 places. So this will be 7 times 10 to the negative 7. Okay, so you should get a pop-up window now asking you to convert these into standard form. I'll go ahead and put the answers here for you so you can check with yourself to see if you got it correct. Okay. And you should get a pop-up window now to convert these into scientific notation. Okay, and I'll put the answers so you can see if you were correct. Okay. Okay, and just as a review of what you have to do for homework tonight, besides watching this video, it is to make sure you bring in an edited word problem for your group tomorrow. You are going to submit those to Miss Nelson and I, so we can hopefully include a couple of them on the test on Monday. You are also bringing in your questions from the previous sections so we can make you a study guide for the weekend. Okay? And this is probably one of your last reminders that we have a test on Monday. Okay? Have a good night.